Alright, just wanted to document this thing I've been working on. An 8-bit computer. On this side, there's not a whole lot populated here, but the processor's going to go there. And there's some RAM half hooked up and ROM that's plotted out. And then logic, which is what I'm working on right now first, because I just want to make sure all that stuff is going to work. So over here, we actually have something interesting. Well, I guess over here I should show. We've got the clock divided down. You were able to divide it by 2 24 times. And it's a 10 megahertz. Over here, we have the front panel, which is what I've really been trying to get working. So we're going to put logic over here. It's not even fully laid out yet because I'm not sure if those are right. And then we got these LEDs. They're pretty cool. We got the data bus over here, and we got the address bus, low 8 bits of the address bus right here. And then we got this really bad dip switch, which is going to be great fun because when I want to put something on the data bus, I'm going to have to push down on this and then hit the right button. But that's what we got. Up here, we got the counter registers that are keeping track of the stuff. So this is going to be for the front panel when I'm taking control of the bus. That way I can use this. So these are presettable. I can load a value into them from the bus. So that's good. It's a little tricky for me to do. I'd have to flick this switch. And then we could... what value do we want? Sure, that's a good one. And then we loaded it. And then to re-enable the counting, go back here, we flick the switch, and we're counting again. So all that's working. We also, I also had to put a buffer on here because these don't have output enables. They're always outputting the counter registers, that is. And then there's just more circuit board up here, but there's nothing much there. Anyways, I wanted to mention a few things. This is the main reason I was documenting this, is I learned, I've never really run into it before, but working with these clocks and debouncing this button, because I also made it so that I can clock it off this button, but I don't have it hooked up that way right now. I have it off the system clock. But I learned that about antennas, loop antennas, and noise. Or not noise, but power. I don't know what you'd call it, but power availability, I guess. Which is why there's all these capacitors on the board now. And you can actually hear this, maybe. But if I take the power out, let it power down, as you can see, it overcurrents my computer for a second to charge up all these caps. So there should be power now. And what was happening was that the counter just wasn't some parts of it weren't working. It had all kinds of noise on it. It was awful. And then the other thing was a loop antenna, which I had with a big loop of wire coming from this Schmidt trigger inverter here, which is what debounces my buttons over to the counter. And it was just, when I released the button, it was just going bloop, bloop, bloop. And I was like, what's going on? I think I'm debouncing it, right? And it was. And what it was I had a huge wire looped up and over into the clock. And that was picking up radio. And generating enough noise to toggle the switch. I'm sure the power availability didn't help that either. But yeah, it's a start. Long way to go.